Hello students, welcome to chemistry class. All right, just a quick story. Let's imagine it's a few years in the future and you're on a job interview and they're looking at your resume and they figure out something. They say, wait a second, you were in high school in the year 2020? Wasn't that the year when school was canceled? I don't want to hire someone who has less education than other people. I'm sorry. At that point, you have to say, school was canceled. Not at Dunwoody High School. We had online learning right from the beginning. And it was rigorous, and we covered the standards, and it was great. I learned a lot, and I can prove it. And that's all you have to say at a job interview. But you have to mean it. So I hope you're working hard at home. I hope you're learning the standards. I hope you're watching these videos once, twice. You're watching the other videos that I'm asking you to watch, and you're doing the work. And do quality work. Some of you are turning in work that looks awfully rushed. I imagine you have earbuds in, and you're shaking your head up and down, and you're just not really paying attention fully to what you have been assigned. So make sure that you are working in silence and you're being serious and you're doing your very best. Okay? All right, well, let's do the opening. Are in 5 days. Let's see if you can solve this. If you can't, I'll show you how to do it, but please take a few minutes, think about it. Maybe you've seen a problem like this in the past in a math class or maybe a science class. Okay, please pause the video now and give it a try. Okay, did you try it? Well, let's go over it. I hope you wrote your answer in scientific notation. It's okay if you got it wrong, but it is important that you try. So please try. When I ask you to pause the video, please do it. All right, to solve this, we will need to convert days to seconds. We'll need to convert days to seconds. That means we will need to use conversion factors. A conversion factor is a number used to convert one unit to another. The conversion factor will cause you to multiply, and sometimes it'll cause you to divide. All right, so let's look at the question again. How many seconds are in 5 days? 5 days. So let's consider 5 days and let's turn it into a fraction. How do you turn it into a fraction? Just put it over 1. 5 days over 1 is the same thing as saying 5 days. So why even bother putting it over 1? It just makes it a little bit easier to see the problem mathematically and to figure it out. So always make things easy for your brain. Set up your equation nice and neat. Always write neatly so your brain doesn't have to struggle reading your own handwriting. And if it helps to set it up as a fraction, then you certainly should do that. Give your brain every break that you can. So I think it's just better when you set it up as a fraction because we're going to multiply it with another fraction. And here's 2 fractions that are options for us. Conversion factors for converting days to hours. Well, we know that there's 24 hours in a day. We also know that 1 day is 24 hours. So you can use either one of these. Mathematically, you're allowed to multiply your value by one of these because both of these is basically a 1. Whenever you have the same number in the numerator and the denominator, that is the equivalent of a 1. Think about a 7 over a 7 or a 50 over a 50. Those fractions equal 1. Well, 24-hour days and 1 day are equivalent terms, so that fraction is a 1. 1 day and 24 hours are equivalent terms, so this is also a 1. So you can multiply these by any value without changing the value. So mathematically, you are allowed to do this. So we're going to multiply 5 days over 1 times 24 hours over 1 day. And what happens when we get that? We get a kind of a weird answer with a weird unit. We get 120 days hours over 1 day. Well, that's a strange unit, not very useful. But because days are in the numerator and in the denominator, we can cross off days. So that's a rule in mathematics. If you have the same value in the numerator and the denominator, they cancel out and you can cross them out. And we could have also crossed it out earlier which is actually a better way to do it. I'll show you that in a moment. Anyway, when we do this multiplication, we get 120 hours. So 5 days equals 120 hours. So that's pretty good. We need it in seconds, but at least we're closer to the answer. Now we need another conversion factor for converting hours to minutes. So we know that 1 hour is 60 minutes. We know that 60 minutes is 1 hour. You can use either of these conversion factors, but choose the one with hour in the denominator. Since we have hour in the numerator here, we want hour in the denominator here so that they'll cancel out. And then one more conversion factor. We need to know that there's 60 seconds in 1 minute. I'm going to choose this conversion factor with minutes in the denominator so that we have minutes in the numerator and they will cancel out. So days and days cancel out, hours and hours cancel out, minutes and minutes cancel out, and all that's left is seconds. Well, remember the problem? We're solving for seconds. So the fact that the only unit left over is seconds means we set up the problem correctly. All right, how many seconds are in 5 days? Well, the answer is 432,000 seconds. How did I get that? I multiplied 5 by 24 by 60 by 60 seconds. So seconds is the only unit left over, and it's 432,000 seconds. There we go. There are 432,000 seconds in 5 days. And the final thing, I did ask you to write your answer in scientific notation. When I ask things like that, please don't forget, I take off points when you turn in work that is not complete. So to make it complete, we convert that to 4.32 times 10 to the 5th seconds in 5 days. So how do you turn this into scientific notation? Well, you want this to be a number between 1 and 9.999. So you put a decimal point right here. You want it to be 4.32. And how do you get a decimal point here? Well, even though we don't see the decimal point, it is right here, and you want to move it over 1, 2, 3, 4, 5 places. And since we moved it over 5 places, it's going to be 10 to the 5th. 4.32 times 10 to the 5th. All right, let's do another one. How many inches away is the sun? Let's assume the sun is 93 million miles from the sun. That is an estimate. You have to estimate it because sometimes the sun's a little bit closer and sometimes the sun's a little bit farther. The sun travels in an elliptical orbit. But 93 million miles is a good, fair approximation. Please figure out how many inches the sun is from us and write your answer in scientific notation. Please pause the video now. Okay, we're back. Let's see how to set up this problem. This is how I set it up. I hope you set it up in a similar way. I put 93 million miles over 1. I'm going to multiply it by a conversion factor that I had to look up on the internet. I don't have that memorized, that there's 5,280 feet in 1 mile. So I just looked it up, and there it is. There's my conversion factor. I want miles to be in the numerator and miles to be in the denominator, so I chose this conversion factor. And I like to see that miles is in the numerator here. That's the whole reason I put it over 1. Just makes it a little bit easier for me to say, and it's really nice when it's always fractions in every part of this kind of problem. Now there's 12 inches in a foot, so that's arranged so that feet cancel out. Miles cancel out, feet cancel out. All we have left are inches. We're solving for inches, so it looks like I set up the equation just right. We're going to multiply 93 million times 5,280 times 12 inches, and we're going to get 5,892,480 inches. That is a lot of inches. And it's not in scientific notation, so I'm going to do the last step. I'm going to convert it into scientific notation. It becomes 5.89248 times 10 to the 12th inches. All right. So we learned how to use conversion factors for things not related to chemistry. I thought that would be a good exercise for us today. Now let's apply it to chemistry. Here is a chemistry problem. The second opening, I'd like you to work this out on paper. Try your best, and then I'll show you how I do it. Please pause the video now. All right, we're back. How many moles are in 3.3 grams of carbon dioxide? You do not need to answer this in scientific notation, but look, please write your answer with proper significant figures. Make sure you don't miss directions like that And when you submit work to me that you follow all the instructions, if you don't give me the answer in the proper way, you do lose some points. Okay, so carbon dioxide, we need to find carbon on the periodic table, we need to find oxygen, and we need to look at their atomic masses. Now, I went to a really accurate periodic table. You don't have to use one that's so accurate, just as long as within 1/100th of a gram is fine. But I found one that's more accurate than that. I have an atomic mass for carbon at 12.0110 and oxygen at 15.9994. Sometimes you'll see slightly different numbers when you get into thousandths and tens of thousandths of a gram. And that's because over the years, scientists adjust these numbers to be a little bit more accurate. All right, so carbon dioxide, don't forget that oxygen, there's two of them, so you got to double that 15.994 value. Then add it to carbon, you will discover that carbon dioxide has a molar mass of 44.0098 grams. Look at that precision. That means that 1 mole of carbon dioxide weighs 44.0098 grams. To solve the problem, you need to use a conversion factor. Well, we just figured out that there's two conversion factors. We know that 44.0098 grams is 1 mole of carbon dioxide. We can also say 1 mole of carbon dioxide is 44.0098 grams. So the question was 3.3 grams. So we're going to multiply 3.3 grams times this conversion factor. Grams cancel out, and we get a final formula of 3.3 moles divided by 44.00098. So I put that on my calculator. Wouldn't want to have to work that out on paper. And I'm going to get 0.0749983 grams. And I guess I'm ready to turn that into Mr. Kruglinski, hoping to get 100 on that assignment. But I won't. Why not? Because the instructions said answer it in significant figures, and this is not in significant figures. Well, I have this wonderfully precise number right down here. My atomic masses were really, really accurate. But look at this, 3.3 moles. There's only two significant figures. Remember that the least precise number determines your significant figures. In that case, it would be this. So 3.3 only has two significant figures, 1, 2. So this answer can only have two significant figures. We're not going to consider this 0 a significant figure, and we're not going to consider this 0 a significant figure. If you don't know why, watch Tyler DeWitt's video on significant figures and zeros. But we would concentrate on this 7 and this 4. That's the two significant figures. The next one's a 9, so we're going to round up. This becomes a 5. And the final answer is 0.075 moles. Did I say grams earlier? I meant to say mole. The answer is 0.075 moles. Did you get that? I hope so. If not, watch this video again and again until you understand it. Or find another resource online for learning this. Or send me an email. Okay, that is the end. And I just want to give thanks to Wikimedia Commons, who gave me that picture of the periodic table so that I could use it for free on my YouTube video. Thank you for watching.